Alright, so this is my Boley Lathe setup here. So I have the lathe. There's a lathe there. This is on a bed. It's a stand. It's basically a lathe stand, and this is a G Boley Lathe, Germany. It's a WW type lathe. It's got tip over tool rest on this side. I'll just move the camera over so you can have a look at it and see what it looks like. So there we go. So it's got a tip over tool rest on this side here. It's got the headstock here with 1, 2, 3, 4 pulleys. I've got a piece of brass in here. I'm going to call it right now. You oil a lathe, you remove the dust covers right here, and right underneath the dust cover there's a small opening there, and you pour oil on this side, you pour oil on this side. This here is a locking nut for the lathe, so you throw your screwdriver into there in that slot right there, and you tighten it, and then it's going to basically pull the collet in. So the spindle, these are cone bearings here on either side, so they have got to take plenty of oil. I use 0W20 synthetic oil. So Bob, I think his last name is Tasconi, recommended using that type of oil, fully synthetic, 0W20. It's very good. And you oil the crap out of it. So you tighten this up until you've got no give on this on the pulleys, and then you loosen up a step. You just jog it back just a bit with your screwdriver, and then you'll see it's loose, and then that way you don't have any play back and forth, so, or end shake, or whatever you want to call it. So you got to make sure that there's no play. That way when you're using the lathe to make fine parts and you're pushing with your graver this way, you don't actually, the headstock doesn't actually move, the collet doesn't move in, that sort of thing. So you get absolute precision, because I'm going down to 0.2 millimeters, 0.2 or 0.09 or something millimeters. I'm very, very detailed. I've made a couple of parts on this already. So that's a tip over tool rest, and you just loosen it up here like this, and then you can slide it back and forth. I'll just do that for a second. And so you've got movement here. I put a piece of masking tape on here because there's a lot of reflection from there. So when you're up close making these parts, it's kind of hard in the eyes. You can't see the details of the part. So when I'm lining this up, I'm lining it up like this to the to that part of the material right there, the stock. And I use carbide gravers because they don't have to sharpen them as much, and they're pretty cool. So, and then there's the tail piece on the lathe here, which I don't have much experience in using. I'm brand new with this stuff. I just wanted to give you guys out there in the YouTube land an idea of my setup. So this stand here, I had another motor on there before, and it looked like this. That's the old motor I put on. Now this is still a very good motor. Probably use it again, but I needed more real estate on the stand. So in order to put in this countershaft, so what the countershaft is it takes the energy from the motor, and it goes from a small pulley to a large pulley. So you got a times multiplier there, and then it goes from a large pulley like this over to the smaller pulley, right, and then it goes to this pulley. So if you do the math on all this, what you end up with is you get very good torque at low speeds with a countershaft. So normally if you took a pulley with a motor and you move the pulley to this, you'd get more torque on the larger pulley and less torque on the smaller pulley. It's kind of like a bicycle with the various gears on a bike. Works exactly the same way. So if I went small here and large here, I'd have more torque, right? So if I move this over to the smallest pulley, and I have this in the largest pulley, and I have this, I'm going to get maximum torque. So this countershaft, this is a pretty old baby here, so it can rotate this way, right? So you can tighten the pulley up effectively by rotating it here, by loosening up this lever here and then rotating it. And it's got, you oil the heck out of it right here, so it's metal on metal, right? This joint here is metal on metal here and metal on metal here, and I can actually just turn this way, take the countershaft out to remove the belts on either side. Now the belts that I made here, let me just spin this around for a second here, see if I can find the joint. The belt is made of a bootlace that I got, and I'm having a fun time trying to find the joint here. Just hang on a second. There it is. So there's the joint there. So what I did was I used 5-pound test line, right, and I sewed the bootlace together with 5-pound test, and that provided, I sewed it about 6 or 7 times, and 5-pound test was thin enough to put into a sewing needle, and then I reamed out 2 holes on either side, and I sewed it together, and I held the bootlaces side by side like this, and then I went like this, and then I straightened the bootlaces out so they were touching this way. So that's how I did it. It was really easy. I did one here, and I also did this belt here. I think this belt is probably, let me see, there's the joint for this one here. This belt is probably too thick for this pulley, but for now it's good enough, so it works. I find the leather belts are a lot less noisy, because I had this orange plastic belt material. Let me see if I can grab some of this really quickly. I had one of these belts on it before, right? Actually, this is probably the one I had on it before, and it was noisy as heck. You could hear it, and the reason it was noisy is that you make the joint here, and then when you make the joint here, I used a Dremel tool to sand off all of the excess material once you melt the belt together. But even though I did that, you could hear this joint coming around the corner every time I use the lathe. So that was crappy. So anyway, so that's the Boley Lathe, Boley Lathe here, and then I've got this mounted here. I think there was already one of these countershafts in here because someone had drilled a hole onto this base before. So everything is put together with wing nuts. That way I can hand tighten everything, so I don't have to use any tools to take any of this off. And then I took this brace here and I drilled a couple holes, and I drilled one hole here, but I realized, and that was for a different motor. And I had another hole up here that I had already in place for this, right? So see if this can actually focus for a second. So I found that you don't need to have, I'm trying to get this to focus, you don't need to have 2 holes to hold the motor in place. You just need 1 hole like this in the wing nut, and there's enough friction between this plate and the wing nut to actually hold this in place. So it works really well that way. So, and then the motor is a sewing machine motor. So it is a 1 amp, if I can get in here, or 0.95 amp sewing machine motor, I think. So it's refusing to focus for me, but what the heck anyway. So it's 0.95 amp sewing machine motor in the back, and giving me plenty of real estate back here to have the motor, and there's a nice focus, to have the motor, the countershaft, and let me give it some power here. The motor, the countershaft, and the lathe all in one base. So I can actually lift this whole thing up in one shot, right? And I've got the, like I showed you before, I think I got the Lucas Lowboy pedal down here, which is a beautiful pedal. It works really well, and it's there we go. I'm having a fun time focusing here. So anyway, this is a Lucas Lowboy pedal. It's basically use your toe to touch down on it, and away it goes. So that's the Boley Lathe here with the Boley Lathe on a really nice base, and with a countershaft. Again, I got this from Uncle Larry's Wash Supplies online. Excellent deal. Thanks again, Larry, for the support. There's a beautiful close-up there of that joint. So that's where I said you have to put a ton of oil, and you can see the joint working in, that's pretty cool. So that was a good focus. And then this joint here is same. So they have to be oiled really well. And there we go. So that's my Boley Lathe setup. Again, I recommend using wing nuts and everything, because the wing nuts will allow you to tighten, loosen everything up by hand. You don't have to worry about anything. So we got some focus there, and this is sewing machine motor. I got a whole crap load of these sewing machine motors now. Once I went hunting, I found more, and these things work at great speed. I'll just pump it up for you for a second here. that's my Boley Lathe with a countershaft and sewing machine motor.